All right, I felt a little bit guilty that I gave you guys a Desmos version, so I'm just going to show you guys how to do all of this stuff on the TI, if there is any tricks, just so you know that you can do it also in your TI calculator if you want. So number one, just kind of said the idea is just plug in the first part and then plug in your answer and see if they match up. So if we go on the TI, I got the nice one now. We got the nice one for class as well. So what we need to do is hit the y equals button, and we're going to type in both of the equations. So this is going to be 16 minus x squared. So I'm going to hit alpha y equals, number one, 16 minus x squared. On the bottom of the fraction, I got 4x. So 4x. And then press enter. I'm going to go to line 2, and am I doing that yet? Nope, I just got to multiply. I go back to y1. Whoops. So I'm multiplying, so I'm going to do times, and we got 8x over x squared, enter, 8x over x squared plus 8x plus 16 plus 8x plus 16. All right, now I'm going to go second line, because second line I want to get my final answer to see if they actually do line up for the most part. So 2 parentheses 4 minus x. Oops, I need a fraction. 2 parentheses 4 minus x over, and I believe this was x minus 4. Nope, x plus 4. It's 4. So if I graph these, as we graph, there's the blue one, there's the red one, so that you can see they pretty much exactly match up. And that's kind of what we're looking for, because if the graphs are the same, that means that, hey, the functions are pretty much the same. Again, the holes, the restrictions here, the 0 and -4, would be the places where they would differ. And if we really wanted to, we could check it by doing a trace. And we can see in the original blue one, y doesn't give us anything. But if we go down to the red one, we do have a point at y equals 2. So we are canceling out that hole when we get our answer. But that's how to do the first one. Since I did say how to do it in Desmos, that's how you can check it in the TI calculator. Number 2 would be the same thing. You could check it that way. Number 3, not really much you could do with 3. 4, if you want, you could plug them in just in order to see that they actually do look like inverse variation. In order to plug them in for the TI, you do have to get y by itself. So like this first one, y equals -6x. Let's clear these out. So we have y equals -6x. If we were to graph that, that's pretty clear that that's just a line. That's not what inverse variation looks like. Remember, inverse variation's got the two swoops. So here, if I've got x times y equals 9, in order to do this one, I would have to divide both sides by x and get y equals 9 over x. Because in Desmos, we're allowed to type it in like this, but with the TI, you have to get y by itself. So if we clear this out and type in 9 divided by x, or you can make it a fraction, we can see we get one that looks like the inverse variation. We can see we've got the two opposite swoops. So it's very clear that that one would count as inverse variation. And again, you can do that with the other two if you want to solve the other two, because that's what you're looking for. You're looking for those two swoops for the inverse variation. For 5, for domain, I kind of showed what we want to do is just type this in. We may be able to see them in our calculator. So y equals x squared minus x minus 2. Oh, I forgot to make it a fraction again, didn't I? Yep. See if it'll save it. Nope. Clear it out. Make it a fraction. X squared minus x minus 2. Maybe. Yep. And then x to the 4th over 81. So we'll do x to the power of 4 minus 81. All right, so if we graph this, and again, we can kind of see our asymptotes. Actually, this is a little bit nicer on the TI than it is on Desmos. We can kind of see what our asymptotes are going to be. We want to get plus or minus 3, and I like these tick marks right here at plus and minus 3. It's pretty clear that that's where we're at. If we want to really double check, TI actually has a nice little trick. You can hit second and then the table, And right here where it says error, that means that the function doesn't exist there. And I can scroll up to -3 and also see that it says error. So I know where it says error, the function doesn't exist. Now we gotta be careful. Could be a hole, could be an asymptote. But since we can clearly see we're going up to infinity or down to infinity, it's an asymptote, it's not a hole. So kind of cool that TI does get a little extra trick on this question. Horizontal and vertical asymptotes, again, we can type it in and use the same trick that we saw to find the vertical one. The horizontal one, you'll just have to zoom out if you want to zoom out. There is also a cool TI trick, though, for the horizontal asymptote, so I am going to put this one in. 1439 minus x squared. All right, so 1 second, insert 4 plus 3. And then this part was 9 minus x squared. And then I have to get rid of everything else. Is that right? X squared, 4x, and 3. Yep, 9 minus x squared. Yep. So again, we can make the graph first. So again, we can kind of see the graph, and we can see 3 looks like it's a good one. But instead of in Desmos where we're kind of looking at it, we can actually go second table set. And here the delta, so this is last time we looked at the table, it was just going up by ones. If we change this to go up by like 1,000 and then do second table, we can kind of see, oh wait, this is where our numbers are kind of headed towards in the table as we get really big. Because again, our horizontal asymptote is what we're headed towards. And if we look at these numbers, -399 over positive 3997, that's pretty close to -1. And the further that we get, the closer we'll actually get to -1. Now let me double check. Why is that all in fractions? Answers, maybe we'll change it to decimal. Sorry, I'm just getting, there we go. So again, we can see now we're at like -1. So here, maybe more at the decimal, but I will tell you if the answer is a fraction, you do want to put a fraction down on the test. So actually having it as a fraction was kind of nice. Let's mode this back to answers, auto. All right, so that's kind of cool that you can do that. It's a nice little trick that the TI has that Desmos does not have. This one, you sketch it. I mean, you probably are going to graph it anyway. Identify points of intersection. I'm just going to go through that one more time, just so we remember how to do that. We've got y equals, let's clear this out, 1 over, we'll do it the old school way. 1 over x, and then -5. So again, if you have one of the older calculators, like my physical calculator, I can't do the little fraction thing. So if you don't have a fraction, this is what you'd want to do. If you want to be really safe, you can just put the whole top, oops, too far, in parentheses. Because again, when we write a fraction, it's like the parentheses are implied. It's like the parentheses are there even though we don't write them. You can put the whole top in parentheses and the whole bottom in parentheses, and that'll work the same way as like the fraction does. Second one is just x squared. And so if we graph these two, so again, we can see something weird's going on. But to find out where they cross in Desmos, you can hit second, and then right here, the trace button will bring up the calculate menu, and we want number 5. We want to find out where they connect, so we want to pick intersect. You can scroll down to it, or you could just hit the 5 button. The way it works, first curve, I have to pick the blue curve. Now I got to be careful because here the blue curve, I'm at 0 and there's an asymptote there. So I actually can't do anything now until I actually get close to it. So that's pretty close to where I think they connect. And then it takes me to the red one, and that looks just like really close to where it connects. So I'll press enter again, and then enter for guess. And then I can see my intersection, 0.1984372. Oops, wrong button. And again, 0.198. So that's kind of how we see it. And how many are there? I mean, visually, we can see that they connected once. Yeah, they connect right there. So that's how to do that one with the TI, in case you wanted to see how to find the points of intersection again, or just wanted a little bit of a reminder. Transformations, if we do want to see this, again, we can graph 1 over x, and we can graph this, and we can just kind of follow the asymptotes along on the graph. I'm not going to show that one. To solve, again, if we want to try and solve it, I'm not going to pick this one because this was one that was all real solutions. I'm actually going to pick this one. And again, we're just going to find where these two things intersect. So 2 parentheses 1 minus x. So let's go to y equals. Oh, let's do the fraction this time. 2 parentheses 1 minus x over, and then we got 3x is on the bottom. All right, press enter because that's the entirety of that side. So I know to stop when I hit the equal sign. Here I've got 1 minus 3 over x. So clear this out. 1 minus, and I'm going to type it old school again, 3 over x, because my handheld calculator, when I was learning, I was used to typing them in like that. We didn't even have the fraction choice. But we graph them, and then the goal is to find out where they cross. So we can see that they cross right there. So again, we're going to hit second, calc, or trace. We'll pick number 5 for intersect. First curve, I want to go over until I'm kind of close. That looks pretty close. Second curve is the red one. It still looks pretty close. Press enter again to guess. And it gives me my value 2.2. Now again, remember the y doesn't count because there's no y's in the original question. There's no y's in here. So I just want the x value of 2.2. And the intersections will automatically get rid of any of those extraneous solutions. So if you solve it by hand, you have to do the check to get rid of the extraneous ones. If you do it on the calculator, there are no extraneous solutions, but you may have to zoom out to find it if the answer is bigger than 10 or smaller than negative 10. So find the quotient, just like number 1, you can plug them both in to see if they match up. I can't really do much there. That's another solve one, just like one we just saw to solve. You can do this side y1, this side y2, find where they intersect. Horizontal vertical asymptotes, we already talked about that. Technically, these ones, the rate questions, once you set them up, they're technically just solve ones. So you could solve them the same way that we did the solve once you get the setup. So this is why in class we said the setup's kind of the hardest part for these ones. But again, just add something over time, you'll be all set. Up to and left to, again, we can just plot each of these and just kind of follow the asymptotes as we go. So not too bad. The one that's a little bit tricky if you rely on your calculator for this is that this part actually doesn't matter too much. This part's just telling you it's inverse variation. It's just telling you want the 2 swoops, and we want to have an asymptote that's up to and then to the left to. I think that was left in my picture, but that's what we do for 17. 18, not much to do. 19, more horizontal and verticals. And then 20 is another solve. So again, with the solve ones, we would do this y1, this y2. Second calc, just find where they cross. Now again, gotta be careful because if the answer is a decimal, that might not be the real answer. It might be a fraction that's the real answer. I'm not asking for any decimal equivalence. I'm asking for the answer. So if the answer is a fraction, the answer should be a fraction. So if the answer is 1/9 and you put down 0.111, that's not the right answer. That's just a decimal approximation. You'd have to know that 0.11 repeating is 1/9, because when we solve, we do want to get those exact answers. So anyway, I just wanted to go over that just because I know in the video that I got and I posted, it's all the Desmos work, but we're using the TI calculators this year. So wanted to do it with the TIs, so a little addendum. So that's everything we got. So good luck, and we'll see everybody next time.